Greetings, coders. In this video, we're going to talk about the four programming language paradigms and where C falls within them. So, what is a paradigm? A paradigm is basically a conceptual approach that different programming languages will implement. And the four paradigms that we will cover in this course include procedural, object-oriented, functional, and the logical paradigm. Now, the imperative paradigm is a broader paradigm that includes both procedural and object-oriented. For procedural languages, those languages go about solving problems by using a sequence of statements, and they will flow linearly through most of those statements. And those statements are created in such a way to they're trying to change the program's state. Basically, they're trying to change variables that alter the flow of the program as you work through. And this is all a very abstract way to think about how programming languages approach solving a particular problem. The code within these procedural languages are organized into procedures, and each one of those is typically responsible for a specific task. So in the C programming language, we have functions, and those are equivalent to the procedures. Each function could do something like, well, you have your main, similar to Java. You have, any function that you create. Say you create a function that gets a line of input from the user, etc. And so the idea is with procedural languages, they break all the tasks that they need to complete down into these procedures or functions. The procedural languages also contain conditionals, loops, and they branch. So they have if statements, and those if statements determine certain conditions, and then based on the conditions, they will go to execute different parts of the code. Similarly, conditionals and branching are used to create loops. So two examples of procedural languages. C definitely implements a procedural language approach. Python's another example. Now, Python also it's kind of a hybrid. It supports other programming paradigms, as we'll see in the next slides. So the next imperative paradigm is object-oriented. And basically, object-oriented is still pretty similar to procedural. There's quite a bit of overlap. And it has black box objects that hide the complexity of the problem they're solving inside of them to a number of different interfaces, whether it's through accessors or some kind of entry point into the object that allows it to execute and run. The state of the program is typically encapsulated within these objects. So inside of the objects, they're also hiding the state of the program. And these objects are independent enough that they can be developed, tested, and debugged independently. Last, object-oriented gives us this capability to reuse code through both inheritance and polymorphism. Examples include C++, Java, C#, and Rust. So as I mentioned, the imperative paradigm has object-oriented. It also has procedural, and you can see that there's quite a bit of overlap here between the two. And this is common across them. The object-oriented and procedural languages or paradigms, object-oriented still implements, the sequential execution of statements. Think about Java, one statement after the other, until you make some kind of function call or method call of an object that then causes it to branch and behave differently. So the nice part here looking at this diagram is that we will spend quite a bit of time learning C first, but it's also going to be teaching us how to program in C++. There's a ton of overlap between the two languages. And this will make it easier to get a strong jumping off point when we jump into C++. The next paradigm that we're going to look at is the functional / applicative paradigm. And these languages typically work at a higher level of abstraction over what we're used to with procedural languages. So there are more functions that are already there that will do operations for us. And in a functional language, you can kind of judge from the name that the functions themselves are very important. So there are a lot more capabilities that you can do with functions. You can pass functions into other functions. You can return functions back out of functions. If you've worked with JavaScript, for example, callback functions are an example of this. There's less use of state in a functional language, especially a purely functional language where inside the function it's not supposed to change anything outside of the function. And when it executes, it's supposed to, given a particular input, always supposed to have the same output. The next paradigm that we're going to talk about is the logical programming, the logical paradigm. And this one is based on a formal logic approach. And out of all of these paradigms, it is the most abstracted from what's going on behind the scenes. From once we break it down into a binary execution on the processor, it's the furthest away from how the execution works. Programs themselves are a series of rules and facts. So there'll be rules that are introduced, say that Bob loves Jean and Jean loves Tom. And based on those facts, we can create rules, and those rules apply the facts and can help us or allow us to create queries based on the rules and facts. And it works through the relationship between the objects, the facts, and the rules to come up with answers to the queries. In this class, we will study the language, the logical language Prolog. We have the procedural paradigm, where we'll study C this semester. We have the object-oriented paradigm, where we'll study C++. Then we'll have the functional paradigm, where we'll study Scheme. And we'll have the logical paradigm, where we'll study Prolog. So the last thing we'll look at in this video is why C is a procedural language. C executes statements one after the other in a sequential nature. And it uses linear flow by default. This means that in absence of an if or a branching statement or a loop, it will execute one statement after the other, after the other, after the other. C programs are organized into functions. So these are procedures in terms of how a procedural language thinks about solving problems. The C programming language has control structures, with loops and conditionals, and it uses variables to store state. These variables can be global or local, so they can be heavily modified by a function, whether they're passed in as parameters, or if they're globals used across multiple functions at once. C does not support objects, so C is not object-oriented. And last, C is at the lowest level. It's one of the lowest level programming languages, other than assembly, where we're down at the actual machine instructions. It is very close to that level, and it gives you, as a programmer, a lot of control over the memory and resources that it utilizes. And that's it for this video.